Okay, welcome back to the video series for the 200-ton oceans problem set provided by the National Maritime Center. In this video, we'll solve the first problem. And it turns out that the first problem is actually a trivia problem, so we won't have to do much math for this at all. And the question reads, the distance in miles between the circle of equal altitude for the observed altitude and the circle of equal altitude for the computed altitude is the blank. Well, the easiest way to do this is just kind of draw out a little bit. And again, this is not an introductory video, so I'm not going to go through the whole method. But if you were to consider this really awesomely drawn circle as the Earth, when we do celestial navigation, we generally set up a navigational triangle. We pick a position, we call that the assumed position. We use the elevated pole, or the pole nearest to us, and we find the geographic position of some celestial body. And we create a spherical triangle between them. And we solve this triangle, and then that helps us determine the line of position from the sun, or whatever body we happen to be shooting. Well, the official name for this method is the St. Hilaire method, or the altitude intercept method. And so to answer this problem, you can do a couple things. You could go onto the internet and read a little bit about the altitude intercept method or the St. Hilaire method. In this version of Bowditch, which does have the glossary, back here, I'll just read you the sample entry for them. And here, the altitude intercept method is the difference in minutes of arc between the computed and the observed altitude. And that's kind of the answer to the question right there. So I'll go into a little bit of an explanation for it, but again, not too much in detail. If you were to kind of take another look at this picture here, and what is really happening is this distance right here is called Zenith Distance. And it's kind of the distance that your assumed position is away from the geographic position of the sun, or the other body, whatever you happen to be measuring. So if you were to plot out all kinds of assumed positions that plotted at the same distance from it, it would plot as kind of a big circle around the GP. And that would be a circle of equal altitude. And then the principle of this method is you zoom in kind of on this section near the assumed position. And down here, if we have the assumed position and the lines that kind of lead away from it, the whole object of the St. Hilaire or the altitude intercept method is to compare the assumed position, circle of equal altitude, with what you actually measured. And so when you zoom in on this area, this circle of equal altitude almost plots like a line. And so that would be the computed altitude. And then if you plotted your observed altitude, you're either going to be some distance away or towards the object, and the distance between this circle of equal altitude and this circle of equal altitude is called the intercept. And so to answer the question, what is the distance in miles between the equal altitudes of the observed altitude and the computed altitude, the answer is the intercept. Looking at the other answers, the zenith distance, we said, is not necessarily what they're going for there. The zenith angle is nothing that we would compute in this. And then the equation of time is used more for solving time-based problems, so nothing in this case. So the correct answer is A, intercept.